Maybe they change the time. Apparently, it's like lots of hours. I think they say like months. We're gonna have roughly 2 hours.
She does have
Okay, let's get started. We're gonna finish week 9 today. Week 9, that means 2 weeks from today is quiz 3. 14 days from today, 2 weeks from today is quiz 3. To get started with this week, I wanted to start by reviewing how to do the written part of the homework, okay? The written part of the homework is you have related samples, and I believe number 1, number 2, number 3 are asking you to do it 3 different ways. One is the p-value, one is the confidence interval, and one is the critical value approach. So I want to show you all 3 ways. So I went ahead from your book. I think this is page 361 if you happen to have the 4th edition. If you got the one that, I don't know what this is, this PDF, it'd be slide 554, but it's example 10.7. It says, let's revisit the chapter's introductory case. Recall that the local ordinance requires chain restaurants to post calorie information on their menus. So here's what's going on. This restaurant has this menu, has customers that have been ordering from the menu before this new ordinance went out. Then this new law comes into place, and now everybody has to list the calories. So this researcher says, hey, but because this new ordinance has our customers consumed less calories, is it a difference calories or less calories? Let's take a look. The nutritionist wants to examine whether the average drinking calories declined at Starbucks after the passage of the ordinance. So let me repeat that. They're going to be able to look up through probably like through credit cards, because everybody's using credit cards. So they can say, okay, we have these regular customers. Let's get a whole bunch of regular customers that we know have bought before the ordinance and after the ordinance. Now we're randomly going to select a certain amount of them. We'll look in a minute how many, but there's however many there are. We're going to look at the same credit card receipts for those same customers before the ordinance and then after to see if they consumed. And it looks like they're examining whether they consumed less calories. So think about that. Less calories. Let me keep going. It says the nutritionist obtains transaction data from 40 Starbucks card holders and records each card holder's drink calories. It could be a club card, it could be credit card, but here's the deal. They randomly selected 40, and they're going to look at the numbers before on those 40 and after, the same 40. The point I'm trying to make is because it's the same 40 people, this is what makes it related compared to independent. It's the same people, just looking before and after. It says a portion of the data shown in table 10.5, can she conclude at 5% significance that the ordinance reduced the average drink calorie that were consumed by customers? Did it make a change in the customers' habits? Because now they know what their calories are that they're taking in. So that's what we're going to see. And is it significant enough? More than 5%. So it's not just a reduction in calories, but a significant enough reduction in calories to be at the 5%, 95% confidence. Solution, we first note, well, let's look, okay? I want you to think of the difference. It would be, this is before the calorie intake. So let's say that the nutritionist is right. They're trying to prove that the person, that most of these 40 people took in less calories. So think about the number before. Let's say they took in 100 calories before the ordinance. They took in 90 calories after the ordinance. 100 minus 90 gives you a number above 0. So the alternative hypothesis would be greater than 0. And then you just know the other one's the opposite. So we go down here and we see the mean difference is greater than 0 because that's what the nutritionist is trying to prove. Before the ordinance, how many calories did they take in? I threw a random number out there. Let's call it, I'm changing it now, 200 calories. After the ordinance, maybe they're trying to take in less calories, so they took in 100 calories. 200 minus 100 is 100, which is above 0, so that's why greater than 0 will be that one. Another hint that we just talked about, that I said I need to share with everybody, is if you're given, let's say you're given the difference. Let me see, is that down here? Here's the difference right here, 210. The mean difference, so if you take, here's before, 141 calories, 137 calories, 147 calories. Here's after, 142, uh-oh, this one went up in calories. 140, this one went up in calories, but this one went down in calories. Now we add all the differences, 84, we divide by 40 customers. The mean difference is 2.1. It is above zero, but is 2.1 calories large enough, significant enough to say that this new ordinance caused our customers to take in less calories? I don't know if that's large enough. But here's my point. When it's a one-tail and your mean difference is a positive, you know then the alternative must be greater than zero, not less than zero. Let me repeat that. Once you realize this is a one-tail, and usually you're going to be given just that mean difference, this number, this 2.10, is going to say the mean difference is 2.10. You're going, oh, it's a positive 2.10, so the alternative must be greater than zero instead of less than zero. If this mean difference is negative 2.10, a negative number, then you can know the alternative must be less than zero. So you can kind of take whatever the mean difference is and let it lead you into what the alternative hypothesis would be. Again, if it's one tail. If it's two tail, you know it's not equal and equal to. There's no thinking about it. It's either not equal to is the alternative, equal to is the null. The hardest thing is the one tail. Is it less than, is it greater than? And you can go jump right to this mean difference, and this will tell you. If it's positive, it's greater than. If it's negative, it's less than. There's the big hint. So you're gonna get those. So meanwhile, we go ahead and find our mean difference. Remember how to do this? Find the difference for every one of the pairs. Then add all the differences together and divide by the number of pairs. So divide by 40, 2.10. Remember how to get the standard deviation of the differences. You gotta take this 2.10, this mean you just found, and subtract each difference by that mean. -1 minus 2.1, -3 minus 2.1, 6 minus 2.1, and then square each of those numbers. The reason I'm pointing this out is because if this is on a quiz, you're probably just gonna be given 3 pieces of data. So it's not a long calculation. You're gonna probably be asked to find the mean difference. You're probably gonna be asked to find the standard deviation of the difference. And then maybe asked to calculate the t-statistic. That's about a 3-point problem right there, just to take it to the t-statistic, but having to show this work that you see right here, showing the difference, showing me you added the difference, and you divided by 3 to get that mean difference, showing me you took that mean difference and subtracted each difference by it, -1 minus -2.1, -3 minus 2.1, 6 minus 2.1, then you squared each one of those. What's next? Add the squares, which come to 2,593, then divide by the degrees of freedom. There's where the mistake's made. You don't divide by 40, you add all those squares up and divide by the degrees of freedom. Let me show you right down here. There it is, 2,593 divided by 40 minus 1. 40 pairs minus 1. Right, you ready for this? Now, what did you just find? You found the variance of the difference. But you need the standard deviation, so one last step is to square root it. And you found the standard deviation of the difference. So the square root of 66.50 is 8.1549. There's the standard deviation of the difference. I want to show you something in your homework before I go on in this problem. Where's the homework? Look what's happening in number 1. Consider the following hypothesis accompanied by the results of a matched pair sample. The mean difference, the null hypothesis, the mean difference equals 0. The alternative hypothesis, the mean difference is not equal to 0. You've just been shown two-tail, all right? So you know it's two-tail because you're given the hypothesis. Then it says the mean difference between the samples is equal to 3.3. If this were a one-tail, the alternative would be greater than, because look at the mean difference is a positive 3.3, not negative. So it'd be a greater than. The sample standard deviation of the difference is 6.2. I'm pointing this out because you didn't have to calculate the mean difference. You were not given the raw data. You didn't have to calculate the standard deviation of the difference. You were given them. But I want you to be prepared just in case, like this problem, where you had to find the mean difference, you had to find the standard deviation of the difference. And then after that, now that you have these two numbers, 2.1 and 8.15, you can find your t, your test statistic. See this 0? The 0 on the right side of the numerator? We ignore that. We pretend that that little symbol isn't even there. We know it's always going to be 0, and any number minus 0 is itself, so we might as well just pretend it's not there. We don't even have to write it down. Is that me? No, that's not me. 2.10 over the standard deviation of the difference, 8.1549 divided by the square root of the sample number of pairs, 40. There's our test statistic, 1.629. All right, this is now we're right just like our homework. Let me go back to the homework. So here's your mean difference, 3.3. Here's your standard deviation of the difference, 6.2. And here's the number of pairs, your sample size, 16. It says use the p-value approach. So you're gonna do exactly what I did. You're gonna find your test statistic, because here's your numbers, right there's your 3 numbers for your test statistic. And now you're gonna find the p-value. Here's how I find the p-value. Equals, here we go, equals TDIST parenthesis, the first number. Oh, did I open this? Tell me I opened it. I didn't open up the Excel equations. Darn, I always forget. Let me go. It's don't forget you need these Excel equations. There's no way you can memorize this, or maybe you can, but I can't. Uh-oh, hang on, full size. Come on. All right, here we go. So out of these equations, out of these 5, oh, come on. Out of these 5 equations, we're using the 5th one down. Oh, no, I'm sorry, we're using the 3rd one down, which is TDIST. It says you're gonna put the test statistic in the first number, degrees of freedom, tell if it's 1 tail or 2 tail, drop the negative symbol if you have one. So there's our refresher as to what goes in there. Test statistic, degrees of freedom, 1 or 2 tail. Now let's go back here. Help me out. DIST.
1.6.
1.6, there you go, 1.629, comma, degrees of freedom.
39.
39 it is, 40 minus 1, comma, 1 tail or 2 tail? What was it? Remember, go back up.
1, right?
No, let's go back up. I tried to remember here again. Let's look right here. Oh, come on, where is it? There it is. What is it?
1.
It is 1 tail. My bad, I thought it was 2. 1 tail it is. We do the math on this and we're gonna get, somebody double check, but the book says we're gonna get, again, that we should get, boom, 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 0.0557. 0.0557. Someone double check that, make sure that's correct, because you never know with this book. 0.0557. So now, what do we compare this p-value to? Significance, exactly. We're comparing 0.0557 to 5%, 0.05. Our p-value happens to be greater than our significance, which means we can or cannot reject.
Cannot reject.
Cannot reject. Anytime your p-value is greater than your significance, you cannot reject the null hypothesis. We cannot reject it. Therefore, we don't have evidence that, I forget what this was.
We do not have sufficient evidence.
We don't have evidence that, what was it? What was happening in this story?
What was it, at 5% significance, we do not have sufficient evidence.
What were they doing? Calories, thank you. We don't have evidence that this new orderance is causing our customers to consume less calories. We don't have evidence to do that. That's what we were trying to prove, that our customers were consuming less calories because of this new law, but we didn't prove it. So it's possibly having no effect on our customers, this new law.
How did you get the 84?
How did I get the 84? Remind me, where's the 84 at?
Scroll down.
Mean diff, where it's 84.
Oh, right there. I added all these differences. If we had all the data there, 141 minus 142 is -1. 137 minus 140 is -3. If I added all these numbers, they'd add up to 84, but it's not showing us all of them.
Oh, okay.
It's just showing us 3 out of 40 of them. But if we add them all, they're all 84, and that's why we divided by 40, because that's all 40 of them added together. So we're trying to find the mean difference.
Then or you could just, then, you just get the difference, usually like highlight the whole Excel and get sum, put sum in the Excel equation.
Yeah, you could, that's right. You're talking about this column
Yeah,
though,
if it was
right?
all shown.
Right, because before this week's chapter, we would find the mean of this column, the before, find the mean of the after, but they're not called before or after, and then we would subtract those 2 means in the numerator. This time, we're subtracting each one of them individually, and then finding the mean of those differences. That's our numerator for this week. So for problems 1, 2, and 3, that's your numerator. Okay, so that was the p-value approach. So now what I want to point out, where did I put it here? I went ahead also and did the critical value approach. Let's remember those numbers. There's our t-test right there. 40 is our sample size. This is a one tail. There's our p-value, but there's our test statistic right there. This is critical value. So all I'm doing is saying, okay, I'm gonna do Excel, TIMV, but look at what I'm putting for the first number, 10%. Because it's a one tail, we have to double the significance for that first number with TIMV to find the critical value. Comma, 39 is that degrees of freedom, 1.6849. So now look at this, 1.629, think of a number line, positive and negative, 1.6849, 1.629 is our test statistic inside or outside the critical value. Think about it, 1.629, 1.68. 6.8's a little bit on the outside, 6.2's a little bit on the inside. Our test statistic is just on the inside of the critical values, therefore we cannot reject. Anytime our test statistic inside the critical values. All right, since our 1.629 is inside closer to 0 than the critical values, that should be plus and minus 1.6849, the null hypothesis cannot be rejected. Now we gotta be prepared to do confidence interval. Here's a, don't forget our critical value, I'm gonna write down 1.6849. Okay, there's our critical value. Here goes confidence interval. We're gonna take our, there it is, our 2.1 plus and minus our critical T, 1.6849 times our standard deviation of the difference, 8.1549 over the square root of our number of pairs, which was 40. We do all the math on this. Let's get to the upper and lower interval. Here they are, negative 0.0718 and positive 4.2718. There's our interval. What number do we check to see if it fits in that interval?
We just have to see if the hypothesis.
The hypothesis number, which is what number?
0.
0. Does 0 fit between that negative 0.07 and that positive 4.27?
Yes.
It does. Anytime 0 fits between the confidence interval, we cannot reject. Let me scroll down, see if I put that on there. Since the confidence interval includes the hypothesized 0 within the range, the null hypothesis cannot be rejected. Therefore, we do not have evidence that the number of calories being consumed by our customers is less now with this new ordinance. We don't have evidence to prove that. How we doing? That was the review. So that now, and I want to now apply it to questions 1, 2, and 3 from your homework. 1, you're given the information and asked just to do the p-value approach only. So you're obviously going to be using this TDIST for it. The second problem is the whole story, which means you're going to include a final sentence telling me after you reject or not reject what it means. Don't forget that. Let me start right now. If this, I don't know if this is one tail or two tail, but look at this, the mean difference right there, negative 2.3. If this happens to be one tail, and I don't know if it is or not, but if it happens to be one tail, would the alternative hypothesis be less than 0 or greater than 0? Less than, because this is a negative number. You can count on the alternative being less than 0 if it's a one tail. I'm not going to read it because this is your homework, so I don't want to, but you're going to use the confidence interval approach on this one, which means you need to use TIMV on this one because you're using the confidence interval approach. And then number 3, you're using the same information from number 2, but you're using the critical value approach, which means you're using that same number you used in number 2 for the critical value, since you're using the critical value approach. And you're going to use the test statistic from, oh, you won't have the test statistic. You have to calculate the test statistic to compare. Everybody understand what's expected for 1, 2, and 3 on that homework? All right. All right. So now let's look at the Excel. Is that where we're going? We're going to Excel? Let's go to Excel. Whoops. This is your homework. Let's go to this one. Here it is. You've gotten some data. T-test paired 2 sample means before and after. All right. Somehow you're told the story, hey, here's before, here's after. You realize this is paired or matched data, So you know you're doing, you're gonna use the data analysis for paired or matched data. I can't remember the title of it, let's take a look. Where am I gonna put this, where am I gonna put this? I already got that down here, but here we go. I'm gonna go data, where's data? Data, then I'm going data analysis. There's probably gonna be numbers there.
It's
Let's
right there on
see.
top of equal
Down at the
variances.
bottom, that's a Z test.
No, I have a t-test paired two sample
Where is it?
means.
Right there?
Yeah, that one.
T-test paired two sample means, there it is. T-test paired two sample means. I open that, let me get, all right, there's nothing here, good. I'm starting by clicking the box labels, just like last week's, or 2 weeks ago's homework, or last week's homework. Click the box labels. Here, I'm gonna put in the significance, hypothesize, oh no, I'm sorry, the hypothesized mean difference is always gonna be 0 for this class. And then here, the alpha is the significance. Let me see what the significance is for this problem. Does it tell us? It probably doesn't even tell us.
No,
It doesn't, let's assume it's 5%, so I'm leaving it at 0.05. Next, where's the range of the first variable data? You've got to include that label, so left click on the word before, hold down your left click, and drag and highlight all the data with the label. All of that. So there it goes, E7 to E20. Now I'm clicking in the dialog box for the second variable. I'm left clicking on the word after in G7, holding left click down, dragging to get all the data, then let go, G7 through G20. There's the second set of data. I have the hypothesized mean difference being 0, I have the labels box checked, I have alpha at 5% significance. Where am I gonna put the output? So how many columns do I need? One, 2, 3, 4. I need 3 columns. I can't put it over here. It's already over here. I'll put it on a new worksheet. Where's a new worksheet? Yeah, I'll put it on a new worksheet, and then we'll just look at this one over here. But here we go. When I click OK, it's gonna put all the output on the new worksheet. There it is. Let me open it up here so you can see it. Here we go. Can everybody see it? Can I make it bigger? Let me see if I make it bigger. Oh, that looks better. You ready? Tell me, this is exactly like a quiz question right here. You're gonna get a picture of an output, and you're gonna have to answer the question. Tell me if you can reject or not reject using, assuming 5% significance, using two-tail p-value. What numbers you're gonna compare, and then tell me if you can reject or not. You gotta, in your answer, tell me what numbers you're gonna compare. Two-tail p-value.
we're going on,
What number?
we're gonna, number 13.
0.028.
There it is, 0.02881. There's your two-tail p-value. Compared to the significance, which is 0.05, cents, 0.02881 is less than 0.05. You can or cannot reject. Can reject. Your p-value is less than your significance. You can reject. And there's your answer to a quiz problem. How many points should that one be worth? We talked about it in the other class, but not with this class.
100.
They said the same as a multiple choice, 3/4 of a point. You guys agree?
You can make it.
You
the
think
whole
this is
term.
harder than a multiple choice, or easier? I think she means easier.
I think it's probably a little easier than.
Easier. So I'm saying about around the same amount of time as a multiple choice, or a little less time. So maybe only a half a point. Let's try another one, just to make sure we're on the same page. Explain whether you can reject or not reject. Explain, also make sure you tell me what numbers you're gonna use using a one-tail critical value. One-tail critical value.
1.7.
Say it again, 1 point what?
78.
1.78229. There's the one-tail critical value compared to, come on,
0.
2 point what?
2.48.
2.48, the t-statistic. You gotta compare the critical value to the t-statistic. 2.48 is the t-statistic. The one-tail critical value is 1.78. Can you reject or not reject, and why?
Reject.
Since our test statistic is outside the critical value, we can reject the null hypothesis. Very good. Very good. That's how you're gonna answer these questions. Now I wanna make sure, let's look at the homework. Where's that at?
It's on the other
Nope,
sheet.
other sheet, thank you. Let me make it bigger. Okay, on your homework, you got data, appraiser 1, appraiser 2. It says right here, use the tool t-test paired two sample means, so there's no question as to what to use there. You gotta use your paired sample means. You're gonna put a table somewhere. You can put the table right here on the worksheet page, or put it on a new worksheet. That's up to you, but you gotta give the table when you hand this in. Same thing as last week. Download this Excel spreadsheet, resave it, add your name to the title somewhere, leave the title, but add your name to it or something. Answer the question, keep saving it, make sure you save it. Now attach it to an email to email it to me with your written answers also, all in one email if you can. But you're gonna put the table somewhere, it's gotta be on there, and then you're gonna type your answer right here to this question. Explain using the numbers from the table you created and the p-value approach if you can or cannot reject a one-tail null hypothesis at 10% significance. Let me repeat that. One tail, 10% significance, you're using the p-value approach. Oh, this is too easy. There should be more than one question on this homework. That's the only question you gotta answer. So put in detail, show me what numbers you're comparing, whether something's less than or greater than something, and then whether you can reject or not reject. There's no sentence telling me what it means because there's no story there. Oh, this homework's too easy. You guys have been given such break after break after break. This has to be your easiest class of the semester. What's so funny? It's not your easiest class?
It's my favorite class, I'll be honest about that. I don't know about easiest.
No one ever calls statistics their favorite class unless they like numbers.
Oh, I hate numbers, surprisingly. It's just all my other classes, they just don't, the teachers don't fix it, honestly.
Oh my gosh, you're scaring me.
Oh, I'm
Wait,
being
we're
recorded.
Should I-
You're gonna have to edit
Should
that.
I don't have time to edit that out, man. Oh my god. Don't.
Upload in slow mo.
Yeah, oh.
Put a mask on. They're coming after you. All right, that's the homework. So now I want to make sure. Let's see, what else do I have prepared here? Is this what I have next? Because I didn't know I was going to go into this next. I want to make sure this is what I want to do. Oh wait, what about this? I forgot about this. Where's that output? Where's that book output? Oh, wait a minute. Hang on a minute. Where was this output? What page was it? Slide 10.8. Okay, right here. Let's look at this output. Here we go. Let's use 1% significance and a one-tail p-value. What numbers would you compare, and can you reject or not reject? One-tail p-value, 1% significance. What are you comparing there?
2.15.
2.15. No! It just looks like it.
0.00000.
Here's what that e to the negative 08 means. It means move your decimal 8 places negative to the left. It means to the left. If that were not negative, you'd be moving it 8 places to the right. But it's negative 08, which means move the decimal 8 places to the left. 0.000000215. There's your p-value. It's so small, so many zeros, that it had to be written with the e. You get that on your calculator sometimes, and you will, so this is what it means. It means, hey, we're not gonna put all the zeros there. You just gotta know to move the decimal 8 places. Now you're comparing that to what? What did I say the significance was?
1%.
1%. Is this less than or greater than 1%?
Less.
Less than. Can you reject or not reject?
Reject.
Reject. That's way less than 1%. It's such a small number. Look at all the zeros. So far less than 1%. You're comparing it to 1%, and then you reject. Okay, good. All right. Now I gotta really make sure you're ready for this quiz. Gosh darn this quiz. Don't forget, the goal is to score better on average than we did in the last quiz. That's our goal. All right? No, period. Well, I don't remember how we scored in the last one. 75, is that what it was? We have to have at least a 79.5 or above average on this third one. That's our goal. So to prepare you, I put together some questions. I want you to think about this, okay? We have not learned proportions yet, but let me review. We started, after the second quiz, learning independent samples, but we were given the population standard deviations, so we knew to use Z. That's number one. I'm gonna read these to you. You're telling me, is it number 1, 2, 3, 4, or 5? Number 2 was the week right before spring break, where there were independent samples, but we were given the sample standard deviations, but there was a sentence that said the population variances are assumed equal. That's number 2, and that's a T. Number 3 is the same thing. These are independent samples. We were given the sample standard deviation, but there was nothing about the population variances being equal. It won't say that they're not equal, maybe nothing's there. But we have the sample standard deviations, population variances are not assumed equal because there's nothing written about it, and it's a T. That's number 3. What we learned this week, related samples, all right, where they're paired together, maybe it's a before and after, for example. That's number 4. Number 5 is what you're gonna learn next week, but we've already done proportions with confidence intervals. We already did proportions with one sample hypothesis testing, so you know what a proportion will look like with 2 sample hypothesis testing. So if I read one of those, which I'm sure I will, you know it's gonna be number 5. Plus, you know there's no standard deviations, right? This is the only one with no standard deviations. That's a pretty easy way to recognize number 5. All right, so as I read this, get prepared to tell me, is it number 1, number 2, number 3, number 4, number 5, and why? And why? Let me make this nice and big so you can see this. Is this posted? Good, it's not. That's the advantage of showing up. All right, you ready? A manager of an industrial plant asserts that workers on average do not complete a job using method A in the same amount of time as they do in method B. 7 workers are randomly selected. Each worker completes the time in minutes and is recorded by the use of method A and method B. The observer generates the following results. The mean difference is 3.3. The sample standard deviation of the difference is 2.8. It says 1, 2, 3, 4, or 5? 4. And how did you know? Yeah, it's the same, good point. It's the same, it's the 7 workers, and it literally said it's giving you the mean difference, which would only be number 4. And it literally gave you the standard deviation of the difference, which would also be only number 4. Hang on now, you ready? 2 tail or 1 tail? Let me read it. The manager of an industrial plant asserts that workers on average do not complete a job using method A in the same amount of time as they would in method B. Didn't mention that they're trying to figure out if they go faster in A or faster in B or less time in one or the other. It just says different time, right? That's what makes it 2 tail. That's why. So we know this is an equal, not equal to. Very good. Very good. Number 4. This is like a quiz question right here. If you feel confident that you can recognize this is a related samples, number 4, I know you're gonna do fine. You guys can all do the algebra. It's a matter of recognizing what kind of problem you have is the key. The setup is where all the points are, recognizing it's the right problem. Let's try this one. A design engineer at Burley Manufacturing, a supplier of high quality ball bearings, claims a new machine process can result in higher daily output rate. Accordingly, the production group is conducting an experiment to determine if this claim can be sustained. The mean and the standard deviation of ball bearings in a sample of 8 days output using the new process equals 2,613.63 and 90.78 respectively. A simple sample of 10 days output using the old process yields a mean and a standard deviation of 2,485.10 and 148.22 respectively. We can assume the population variances of these 2 products are equal. 1, 2, 3, 4, or 5? 2. Were you thinking 3 though until that last sentence? I did too. I forgot what it was until I got to that last sentence, and then I saw that it said that the population variances of these 2 are assumed equal. That's how you knew it was number 2. Wait, did you say 3 or 2? Okay, I thought it was 3, and that's how you knew it was number 2, is that last sentence right there. If that last sentence weren't there, this would have been number 2. Now what's crazy about it, this almost read a little bit like related samples until it said it used 8 days of output under the new process, and then it used a different 10 days over the output over the old process. They were not the exact same days, they weren't the same people, so it just kind of read like it was related, but it wasn't. And the other key was it was giving me the mean and the standard deviation of each sample instead of the mean difference. That's another big hint to help you realize it's not related. Okay, these are almost too easy. I'm happy to see that.
Would that be a 1 tail?
Yeah, good question. Let me go back. 1 tail or 2 tail. The design engineer, spring manufacturer, supplier of high quality ball bearings claims a new machine process can result in a higher daily output. One tail or two tail? One tail, because of the higher daily output. If it said a different daily output, would have been two tail. If it said a lower daily output, one tail. Higher daily output, lower daily output, one tail. Different daily output would have been two tail. Should I go ahead and figure out if the numerator would be positive or negative? That'd be 2613 minus, what comes first, the old process or the new process? What order are they doing this in?
The old minus
I don't think it is the old minus the new. The mean and standard deviation of all variance from 8 days of the new process, so there's the new first. 10 days of the old process, there's the old. It looks like it's new minus the old, which would be 2613 minus 2485, which would give us a positive numerator. Positive numerator, which means that since this is a one tail, the alternative would be greater than 0. You can look at the numerator, and if it's positive, just like the mean difference, then you know the alternative hypothesis would be greater than if it's one tail. If this would have been subtracted to a negative, the alternative hypothesis would have been a less than 0. All little hints to not lose any points on any of this part. All these details. Despite his inexperience, candidate A appears to have gained support among the voters. 3 months ago, in a survey of 120 registered voters, 55 said they would vote for candidate A. Today, 41 voters said, of a sample of 80, said they'd vote for candidate A. Constructed 95% confidence interval to determine if the null hypothesis could be rejected. 1, 2, 3, 4, 5. 5. There's no standard deviation in here. It's obviously a proportion. This is number 5. Now, I wanna. There was a key word there that would let you know if this is one tail or two tail. Is it one tail or two tail? And what's the key word? One tail, because gain. Says it appears he's gained support among voters over time. So gained support over voters. One tail. Now, if I did the math on this and took 55 divided by 120, then I took 41 divided by 80, and I said, okay, a gain in supporters would be a higher percentage. So let's say one's 44%, the other one's 52%. You subtract them, you would have a negative number, which means the alternative hypothesis should be less than 0.
So then it would be greater than 55 is the null, or greater than equal to 55 is the null?
No.
Or I mean less than?
No.
The alternative would be
Always 0. Always 0. Always 0. So in this case, it would be mean 1 or proportion 1 minus proportion 2 is less than 0 and is the alternative. Now here's why I said less than. I'm assuming that 55 divided by 120 is a percentage. I threw one, I don't know what it is. Let's call it 0.25. And then 41 divided by 80, that's like 0.5. So 25% minus 50% gives me a negative number. So the alternative's got to be less than 0. This whole quiz 3, every hypothesis has to do with a 0. You know the number's 0. You can't get that wrong. It's just a matter of, is it less than 0, greater than 0, or is it not equal to 0? The alternatives are one of those 3. Less than 0, greater than 0, or not equal to 0. We got a couple more. Are these helping?
Yes.
They are? Okay. Because I think this is the hardest part of quiz 3, is reading these problems and know exactly. And then what I would do for my cheat notes, for my, where you're writing notes, taking pictures, have them ready for you while you're taking the quiz. Once you identify which one it is, now you turn to your notes based on whichever one it is and start looking at the 3 processes: p-value process, critical value process, confidence interval. Then you go, how am I supposed to solve this? And then you just do it just like you have in your notes. Use your notes as your guide. Nothing has to be memorized. You just have to be well organized and know where to look to find the help you need based on identifying the problem you're reading. That's the key to this, is identifying which one of these 5. These are basically the only 5. Even if we study variance that lecture before the quiz, I'm not going to give you any problems on comparing variances. I'm only going to maybe give you a multiple choice question. So as far as problems concerned, here it is. These 5 are the only 5 you got to figure out which one to use of these 5 for where most of the points are on this quiz. Did we do this one already? No, we didn't. According to the health, have we done this? No. According to the health, to a Health of Boston report, female residents in Boston have a higher average life expectancy compared to male residents. You collect the following sample data to verify the results of the report. You also use historical population standard deviation of 8.2 for females and 8.6 years for males. Females mean are 82.1 years of age. Male mean is 76.2. Wow, 76.2 seems young to me. Wow. Number of females is 32 in our sample. Number of males is 34 in our sample. Is this 1, 2, 3, 4, or 5?
1.
Oh, I heard several different numbers. I heard a 4, I hear a 3, I hear a 1.
1.
I hear a couple more ones.
Say 1.
Why is it 1?
Because you know it's the mean 1 minus the mean 2 and.
No, that's not why it's 1. Because you're being given the population standard deviations. That's why it's 1. Right there it says you also use the historical population standard deviation of 8.2 and 8.6. That sentence tells you it's number 1. Population standard deviations. You gotta get used to that. Okay, now jump in with your one tail, two tail. Wait, let me read it again so I know. One tail or two tail. Let's see. According to a Boston, female residents have higher average life expectancies. It doesn't say different average. It says higher life expectancy. So that's why this is a one tail, correct? It's a one tail because it says higher.
Greater than?
Would the alternative be greater than or less than? Let's see. We're comparing what's females are on the left, males are on the right. So we got 82 minus 76, which would be a positive number above 0. So our alternative would be greater than 0. The null would be the less than equal. You can always, whatever the numerator is, tells you what the alternative would be if it's one tail. Or else it's going to be not equal to 0 if it's not one tail. I think we got one or two more. Here we go. The phone manufacturer wants to compete in the touchscreen phone market. Management understands that the leading product has less than desirable battery life. They aim to compete with a new touchscreen phone and is guaranteed to have a battery life significantly longer than the leading product. A recent sample of 120 units of the leading product provides a mean battery life of 5 hours and 40 minutes and a standard deviation of 30 minutes. A similar analysis of 100 units of the new product results in a mean battery life of 8 hours and 5 minutes with a standard deviation of 55 minutes. Use your p-value approach and 5% significance to determine this. 1, 2, 3, 4, 5. Oh, what was that hesitation? This should have been easy. 1, 2, 3, 4, 5.
3.
3 it is, but why?
Because they're not assumed.
The standard deviations are the samples. It was the collection of, how many phones? 100 new phones? What was it? 120, the leading product battery life gave you 5 hours and 40 minutes with a standard deviation of 30 minutes. That was the sample standard deviation for those 150 phones. Then it says 100 units of the new phone gave you a mean of 8 hours and 5 minutes, standard deviation of 55. It was the sample standard deviation. Then there was no sentence about the population variances being equal. That's how you know it's number 3. That's how you know it's number 3.
How can that not be number 1?
Because it's not giving you the population standard deviations. It has to give you the population standard deviations to be number 1. But each of these standard deviations are part of this, it's reading all about the sample. It was right after the sample mean, all in the same sentence. So it's the sample standard deviation. So once you realize the sample standard deviation, you know it's number 2 or 3 because they're not related means. It's just a matter now, does it have that sentence talking about assuming the population variances are equal? I think that's the last one. Let me see if it's, oh, one more. Oh, good question. I almost forgot. Hang on. We're trying to figure out if it's one tail or two tail. A phone manufacturer wants to compete in the touch phone. Management leading products is a better life. They aim in the touch screen guarantee that the battery life is significantly longer. One tail it is. One tail it is. Now let me look at the two means. Let me see if we're gonna, now this one tail, is our alternative hypothesis a greater than or less than? So I'm gonna look at the two means. One is 5 hours. The second mean is 8 hours. 5 hours minus 8 hours gives you a number below 0. So our alternative hypothesis would be less than 0. Because the numerator of our test statistics is going to be a negative number. So less than 0 would be our alternative hypothesis. Oh, these are a lot of great hints to get all those extra points on quiz 3. We're going to do so well. I feel it. By the way, what's that 8 mean? What is it? 8? 8.
Oh, wait, no, I said.
This is a
E.
trick question.
8 questions on the quiz.
How, what?
8 questions on the quiz.
Ooh, that's a good answer, but no.
Wait, which 8 are you talking about?
That 8, that's the circle right there.
We have 8 minutes?
No. 8 minutes, 8 minutes.
That's
You know, we gotta get started on the in-class, it's a long one. What does the 8 mean?
8 minutes per question.
8 what?
8 days till spring?
No, gosh, is it true?
Is it 8 minutes
that
per
true?
question?
8 what?
8 days till the quiz.
No, there's 14 days till the quiz. There's only
8
8
points
more
extra
lectures
credit on
till
the
this
quiz.
semester's over. There's only 8 more lectures, that's it. After today, you only have to hear this stuff 8 more times and your semester's done, your class is over. That's it, we're only meeting and having to hear stuff 8 more times. You're so close, you're so close to being over with. You're almost done. This is our last one, and then we gotta get to our in-class, you ready? We're trying to figure out if this is 1, 2, 3, or 4, or 5. Do women really spend more money on shopping as compared to men? Okay, one tail or two tail?
One.
It didn't say, do women spend different amount of money than men? It's saying, do they spend more? That gives it away, it's a one tail. The survey found that women spend an average of $43.87, while men spend an average of $34.54 per week. This must be old. I don't even know what to say this. Assume that these data were based on a sample of 50 men and 56 women. The population standard deviations of spending for men and women are $32 and $25 respectively. Specify completing the blah 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 10% significance. Here we go. 1, 2, 3, 4, 5. I hear 1 and 2. Tell him what.
Population standard deviation.
It's giving you the population standard deviations.
Oh, I thought it just said standard deviation.
No, population. It says, and the population standard deviations for spending for men and women are 30, 20, 32, and 25 respectively. That's the key word right there. That's why it's number 1. Number 1, because of population standard deviation.
That's what he said.
Are we going to be able to figure out every one of these questions on the third quiz? Don't forget, the third quiz is going to be a little longer than the second quiz. The second quiz was 6 questions, right? 6 questions, so you should plan at least 8 questions. Out of those 8 questions, I think 4 or 5 will be problems. And so you gotta be ready for, think about it, we got 5 of these, so 5 problems, you know me, probably each one will be a different one of these. What you gotta be prepared for though is, you gotta be prepared to use any one of the 3 approaches for any one of these 5. So this one may be p-value approach, that one may be critical value approach, this one may be confidence interval approach. So you're probably gonna have 5 problems, probably these 5 equations, but you don't know which approach each one of them is gonna be. So you gotta be prepared for all 3 approaches. Oh my gosh, I just gave such a big hint. Because you're gonna start now, I start reading the 5 problems and say, oh, this one's definitely this one, this one's definitely this one. And you can almost logically then, this one's really hard, I don't know which one it is. But there's only one that's not on here, so maybe it's the one that's not the other 4. I'm just giving away too much information. All right, you ready for the in-class? Okay, it's gonna take a while. Now we gotta pretend I'm not here. Is that true? And please compare to people in at least 2 different rows other than your own row before you hand it in. 2 other people. And you're comparing the work, not just the answer. All right, so here we go. A report criticizes, let me see, where are we at here? A report criticizes SAT test prep providers for promising big score gain without any hard data to back up such claims. Suppose 12 college-bound students took a mock SAT, then they completed a 3-month test prep course, then they took the real SAT. The experiment results as follows. Mean difference, mock scores minus the real score ended up with a negative 34. Standard deviation of the difference, 52. Give the hypothesis, show details solving manually, including the Excel equation used for either the p-value or critical value, and explain if you can reject or not reject using 4% significance and all 3 approaches. All 3 approaches. You're showing p-value approach, you're showing critical value approach, you're showing confidence interval approach. Now, here's my big hint. I started today's lecture showing you all three approaches with example 10.7, exactly like this question right here. So what you just heard in the beginning of this lecture was preparing you for this question. All three approaches. Don't forget, at the end of showing all three approaches, give one sentence that explains what your reject or not reject means related back to here. You're gonna tell me whether the evidence suggests that this, what is this, this class, what's it called? Dang, 3-month test prep course worked or didn't work. Did it work or didn't work? Do you have evidence that it worked or it didn't work? All right, good luck. You got an extra time to get this one done because you're doing all three approaches. Is there anybody that forgot to sign in?